चलो, हाय गाइस, वेलकम बैक। आशा करते हैं कि आप अच्छे होंगे। होप यू आर डूइंग गुड। My name is Adil Khan. I am your chemistry teacher in Base Education Services Private Limited. So you must be hearing my introduction from last 7 videos. So this is your 8th session of introductory course or the bridge course for first year, standard 11th or first PUC, whatever you call in your language. तो चलते हैं, we'll take off the flight. So in the previous session, I have given you some question. The session was of balancing and chemical equation wala stuff. So some question of the day we need to discuss. So these questions I have given you, and I believe that you have balanced it. Chalo, what is the answer for this? So if I'm not wrong, it is this. So 4 hydrogen, here 4 chlorine, and here 2 plus 2 chlorine, 2 plus 2, 4 chlorine, 1 manganese, 2 oxygen, 2 oxygen. This is absolutely balanced. Good. Move to the second. You don't do like this, that make it 8 and all. You have to have lowest number, okay, whole number during balancing, okay, as much possible, least number you have to keep. Now, second one, already we have discussed this. So tell me the answer first. So it will be 23 and 43. 4 iron, 6 oxygen, 3 carbon balanced. Similarly, carbon dioxide and S-8, it is sulfur, giving carbon disulfide and sulfur dioxide. What will be the balance? So if I'm not wrong, 83 and 88. 8 carbon, 24 oxygen. So 16 here and 8 here, 24. Oxygen 16, it is balanced. 83, 88 is the balancing for that. Next is phosphorus. Basically, it is a white phosphorus, which is poisonous in nature. So basically, in the matchstick and all, you have the red phosphorus. So the red phosphorus formula is also same, P4, but it is N number of time. So P4 plus oxygen giving P2O3. Balancing will be what? So 3 and 2, I believe. So this is 4 time and this is 4 time. 6 time and this is 6 time. Any doubt in that? Very good. Let's move to the fifth one, that is hydrogen, and it is V2O5, vanadium pentaoxide, and giving V2O3 and water. What will be the balancing? So it will be this 4, 4, 2, 2, 3 plus 2, 5, 3 plus 2, 5, it is balanced. So this is the way you need to balance the equation. As I said in last class, you need to do practice. There is no shortcut for this. The more you practice, more you learn. The less you practice, less you learn. That's the simple fundamental of chemistry. Let's move to the next session for the day. What is this, guys? This is a ball, right? If you tennis ball or what, you play cricket with this, right? So this is a ball. What it represents, by the way, in chemistry. So in chemistry, in layman term, it just looks like an atom. Atom is spherical, or you can tell it is like this. So today we are going to study about atom, but not only about atom. We are going to study that what it is made up of. So that is our area of bridge course today. So this image, what are you seeing, is microscopic image. Microscopic means under electron microscope they have took this image, and this is an image of an atom, and you will be surprised to know that it is nothing but your hydrogen atom. Hydrogen atom is represented as capital H. So this is your hydrogen atom under microscope. It is so small that you cannot see through your naked eye and even normal microscope. So highly sophisticated microscopes are required. So example is electron microscope. So today's topic is atom and its subatomic particle, that what it is made up of, how it was discovered, and few characteristic feature. So this is your topic of the day. So today, session 8, atomic structure. You would have read in your 9th standard in CBSE. ICSE kids also and state board also have brief knowledge about it. So atomic structure, when you talk about, it is nothing but about atom, the structure of atom, and discovery of SAP. SAP stand for subatomic particle. Subatomic particle means it is those particle. Basically, particle means anything which has mass. Particle means anything which has mass. So subatomic particle means an atom is made up of these all things. So atom, when you see on Google, it looks somewhat like this. Now, before coming to this image, the concept of atom came into existence 13.7 billion years ago. It is believed that 13.7 billion years ago, the atom existence was originated, or atom was origin. And what happened 13.7 billion ago? It was Big Bang explosion which took place. So 13.7 years ago, it is believed by the scientist that first time atom existence was known. I'm giving you timeline of atom, okay, how we moved. Then there was a Greek philosopher known as Aristotle. In around 350 BC, that is before Christ, he said that atom, matter is nothing but it is made up of matter, not atom. Matter is made up of air, it is made up of water, earth, and fire. But he did not have any support for it, so that concept failed. Basically, atom is what? It is the building block of matter. That's why Aristotle tells that matter is made up of air, water, fire, and earth. So it is a failure because he did not support. Our Indian means our Indian, like Maharishi Kanad or old priest, or you can tell Gurujis and all, they have also given a concept of Anu and Pramanu. So we Indians also have contribution other than Greek people or Greek scientists. The next in the timeline of atomic history was Democritus. So Demo, at around 400 BC, he came up with the idea of atom. And what he said that, suppose you take a stone and break into small pieces. You take that small pieces and break further into small pieces. You take that small pieces and break further into small pieces. And at a moment, you will reach a point where that stone particle or stone part do not break further. And that part which do not break further, he regarded as atom. So this was Democritus' idea, but later it was also proved to be wrong. The real idea or concept of atom came into existence in 1800 when a British high school teacher, Mr. John Dalton, came up with a theory known as Dalton's atomic theory. You will read that in standard 11th. It has some around 5 to 7 points you will read. One of the most important point what Mr. John Dalton tells in Dalton atomic theory, Dalton atomic theory is nothing but that he tells that atom is electrically neutral. So this point hold good till date. After that, after some time in 1827, there was another scientist known as Mr. Robert Brown. Mr. Robert Brown, John Dalton was a British high school teacher, whereas Mr. Robert Brown was a biologist, basically a botanist. So he has studied the concept of Brownian motion. Brownian motion means the flower, small pollen grains, what it has, it move in a zigzag motion like this. So from there, he has given the concept of atom. So this is the timeline of atom, that how atom basically known in past and at present also. The word atom come from a Greek word atomos. It's a Greek word which means indivisible. Indivisible means you cannot divide it or break it, but it is wrong. Dalton atomic theory faced the first blow or first demerit or first failure when the British chemist or British physicist rather, that is Sir J.J. Thomson, discover electron. So we will study about that. So this is all about atom. For your knowledge, atom is fundamental building block of a matter. If anyone asks what is an atom, please tell it is a fundamental basic building block of an atom. In this session, we are going to study about atom, and that atom is made up of 3 subatomic particles, although it is made up of many other things which is known as quarks. But the 3 subatomic particle is proton, which is positive in nature, electron, which is negative in nature, and neutron, which is neutral in nature. First discovery of electron was done, followed by proton, and followed by 1932 neutron was done. We will see the discovery of all these things. But you must know that atom is not only made up of these 3 things, it is made up of even more another type of particles inside it. But our area of concern of these 3 subatomic particles, electron, proton, or neutron, let's start that. So Mr. John Dalton tells that atom is neutral. I agree. So Mr. J.J. Thomson, rather Sir J.J. Thomson, he belonged to Britain. He thought that inside atom, maybe something is there. And he thought to conduct some type of experiment. He did many permutation combination, many trials, faced many failures. But ultimately, he comes with a successful experiment known as cathode ray tube experiment, or it is also known as discharge tube experiment. So cathode ray tube experiment. So what he has used a cathode ray tube. So this is just like the big 2-liter bottle of Coke or Pepsi, what you have, or 7-Up. It looked like that. So it is made up of cylindrical glass and 2 metallic plate he has fixed. So it is known as your electrodes, and then it is linked with a DC source. DC means direct current, or you can just tell it is linked through a battery. And this is further having a vacuum pump, or you can call it as a suction pump to remove or reduce the pressure inside. So the negative terminal of the battery is connected to the negative pole or negative plate known as cathode, and positive terminal connected to positive plate known as anode. So this is nothing but your cathode, negative, and this is nothing but your anode. And inside this, air was there. So vacuum pump function is to reduce the pressure by removing air. So one thing was known. Faraday has done an experiment before this, and even Mr. J.J. Stoney. One thing was known that about something current, that Farwala experiment, you take scale and rub on your hair, and small bit of paper you can attract, and even in winter, the woolen cloths and all. So static current wala part, So that concept was already known at that point of time. So cathode ray tube experiment at the end of the 19th century. So this was done at around 1897. Okay. So at the end of the 19th century, it was found that normally dry gases means which is not having moisture in it, do not conduct electric current. That's why in summertime, when there is less moisture in the air, current do not pass. Otherwise, in summer, we will get electric shock near the electric source. But they do so under very low pressure, and the patches of light are seen. That is an experimental part. So it is seen at extremely low pressure. That's why the suction pump was there to generate extremely low pressure. So what he did multiple trial, but his best trial was when he applied a pressure of 10 to the power -4 mm of mercury. Mm is the unit of pressure, that is millimeter of mercury, mm of mercury, and at around 10,000 volt, that is the DC source. At these 2 conditions, the best observation he could see. So at 10 to the power -4 mm of mercury and 10,000 volt when he has applied on this, what he see that something comes out from the cathode, that is the metallic plate, and it come and hit the area surface here, okay, and it is coated with zinc sulfide screen. Behind anode, the areas are coated with zinc sulfide. Zinc sulfide is the chemical which is known to produce color when it is hit by some electrically charged substance, or when it is hit by some charged substance like electron. So zinc sulfide screen was there, that is ZNS. So, and this, what is coming out, he referred it as cathode ray. Why he referred it as cathode ray? Because he thought that its origin is cathode, that's why it is cathode ray. And since cathode is negative, the cathode ray which is coming out will be negative, because generally human produce human, dogs produce dog, snake produce snake, lion produce lion. So cathode will produce cathode. Same concept was there. So when current was applied, cathode ray was seen moving towards this side, and a green glow was there. So this was an experiment at 10 to the power minus 4 and 10,000 volt. Okay. So when a current of 10,000 volt is passed through a gas of air kept at a very, very low pressure, 10 to the power minus 4 mm of mercury, blue rays were seen emerging. This is the rays color you need to understand. These rays are called cathode rays. Okay. Now this cathode rays, now Mr. Sir J.J. Thomson tells that it is negative, but he did not coin the term electron. The electron term was coined by some other scientist. His name was G.J. Stoney. And he coined this term in 1891 only. After seeing Faraday experiment, you leave that part. 1897, this electron was discovered, but the name was given in 1891 by G.J. Stoney. He tells that electricity is, just remember that G.J. Stoney has given the term negative. I'm not going much in depth. He has given the term electron to the negative charge, that is cathode ray. So electron was discovered by Sir J.J. Thomson, that's right, in 1897, but the name was given by G.J. Stoney in 1891, and that was 1897. Discovery 1897 and name was given in 1891. Got it? So extremely low pressure at high voltage, when current is passed, cathode rays start moving from cathode to anode, and when it hit the zinc sulfide screen, this is ZNS screen, it produces a glow there. Okay. So have you seen fireflies? So it has a chemiluminescence inside, just like that of color it produces. So just you can relate like that what you mean by fluorescence. Fluorescence means giving out light. So this was the thing. Now we need to study about cathode ray characteristics or properties. This is the most important part, not the experimental part. So cathode rays properties we are going to see. Important properties of cathode rays, there are many. I have selected 8 important ones. So they travel in a straight line. They means cathode ray. From here onwards, cathode ray we will represent as CR, not class representative, cathode ray it is. So they travel in a straight line from cathode towards anode and cast shadow of metallic object placed in their path. For example, this is your suppose cathode ray or discharge ray tube. Suppose you put a cross. The cross, have you seen Jesus Christ wala cross? What our Christian brothers and sisters they wear. So when they put, so when cathode ray passes through this, a shadow was seen. Okay, so here a shadow was visible like this. This is nothing but the shadow, and everywhere else cathode ray is passing. So this proves that cathode ray is moving in a straight line. So first thing, it move in a straight line. That is important. Second, they causes mechanical motion to the spin wheel placed in their path. They possess kinetic energy and must have material particle. What is, in one word, suppose this is my cathode ray tube. Have you seen that spin wheel? A very lightweight, basically a mica spin wheel they took. So spin wheel means which rotate when some material means mass thing move. So when the cathode ray is moving from cathode to anode, this spin will start rotation, either clockwise or anti-clockwise, depend which cathode ray hit first, the bottom one or the top one. So this proved that it is material in nature, this particle in nature. Particle means it has having mass. So cathode rays are having mass. I have a diagram in the next slide. I will show you that. So they have mass, particle nature, meaning that. And they produce fluorescence when they strike the glass wall of the discharge tube, which is coated with zinc sulfide as material. Fluorescence means emit out light. So it will glow light outside. Fourth point, when they strike the metal foil, it become red and start glowing. So you can take the metal foil like aluminium and all, a very thin foil. So it start heating and glowing because it is having mass and it is having charge. Charge is negative and mass also it has. Fifth point, they produces X-ray when they strike a metallic target. Okay, so there was some disturbance. So I was talking about the fifth point. The fifth point was they produce X-ray when they strike a metallic target. So when cathode ray, when you take and hit the metals like you can take copper, you can take molybdenum, you can take tungsten. So copper, molybdenum, and tungsten, or many other things, but these three are the common. When hit by cathode ray, they produces X-ray. X-ray, same thing, which is used to investigate the broken bones and all. So that is important. Sixth point, they ionize gases through which they pass. Ionize means it produces charge on them. For example, if suppose cathode ray is passing through hydrogen, okay, H2, so it will remove electron and produces H plus, and 2 electron is out. So here when you see H plus, it is having a charge and it is ion, so it ionizes gas. Reason for that, it has mass, and second reason for that, it has charge. That's why it has high energy to ionize any other gas in the vicinity when it is moving at a high speed. Seventh point is important. You know that electrons are negative, right? Electrons are negatively charged. So if suppose electrons are moving from cathode to anode, and you put a electric plate, okay, electric positive pole and a negative pole, electric field, what we see that this cathode ray deflects towards positive side of the pole. Reason for that, the cathode ray itself is made up of negative and positive attract. It will not move towards negative because negative will repel. So since they are negatively charged, therefore they are deflected in electric and magnetic field. Same thing in electric field, it will be deflected towards the opposite end, and magnetic field also it will do the same. And different gases produces same cathode ray. This indicate that particles present in cathode rays are fundamental constituent of all the matter. So whether you take hydrogen gas, you take it as helium gas, you take it as oxygen gas, you take it as argon gas, whatever cathode ray comes out, it will contain electron. And you know electron from my body, or when I take from the mouse body, mouse means the computer wala mouse, this one, or this pen body, it will be same. Electron will be negative, it will have the same mass and the same nature and all. So these are the 8 different points. One more point I would like to tell you that, you know, the old cameras, that click wala camera, not digital, which is having a reel, black color reel. Have you seen? If you have not seen, then Google it. So that reel will be having that film, black color film, on which the photographs or pics are captured. So when you hit that film with cathode ray, it will affect that, and this process is known as fogging. So the film will be affected and the process is known as fogging. So these are the important 8 points which you need to know. So first, it moves in a straight line. Second, it has particle in nature. Third, it produces fluorescence. Second, it produces heating effect on the metal. It produces X-ray. It ionizes gas. It deflects in electric magnetic field. And for different gases, it is same. Now, the four important point, there is a diagrammatic visual here. So when you see this, this proves that the first diagram, that it moves in a straight path. It moves in a straight line, and it is moving from cathode negative to anode. Cathode to anode it is moving. This is first thing. Second thing, this tells us about this second image about fluorescence. That fluorescence means emitting of light. You could see that how the light is emitted. Third is effect of magnetic field. So this is a magnet this person is holding, and the cathode ray is deflecting downwards. Okay, generally it goes downwards with respect to north and the south pole. And the fourth image is, this is the cross what I was talking, that if you keep a cross, when you see the cross is somewhere here, you could see a shadow here. So these are the four important points which you need to know, that first, it travel in a straight line. Second, it is deflected in electric magnetic field. Third, it is particle in nature, and that too negatively charged particle. And next, it produces glow or fluorescence when it hit material which is like ZNS and causes fluorescence. So that's all from the cathode ray. I hope that is clear. So it was discovered by Sir J.J. Thomson in 1897. The name was given by J.J. Stoney. It is negatively charged, straight line, fluorescence, deflected by electric, magnetic, and material nature. These are the important stuff which you need to know. Now, I have told you in start that John Dalton tells that atom is overall neutral. Agree? Now, inside this atom, now electron is discovered. Electron is represented as E minus. But the neutral concept gone then. So many scientists, they started thinking that if atom is neutral, to balance this negative particle, there must be some positive counterpart to make it neutral, because one positive, one negative make it neutral, five positive, five negative make it neutral. So many scientists tried experiment. Ultimately, there was a scientist known as Edwin Goldstein. He's a German. Sir Thomson was British. He is German. So the credit of discovery of proton goes to him. Now, don't get confused with the proton inside atom. So it has a small fundamental deviation, but it lands right. I'll tell you why. It is not exactly that proton what you thought, but it is that only with a different twist. So Mr. Goldstein, he did the same experiment. He took the cathode ray tube. The setup is same, everything same. It is a glass cathode ray tube. He took two electrodes. Electrode means metallic rod. Two difference he did. The difference was he took perforated cathode. Perforated cathode means like this. You could see in your washroom and kitchen, this is the sink which hold the unwanted stuff to go into the main line. So this is known as perforation hole. So he used a perforated cathode. And basically this was aluminium perforated cathode what it has used. And anode was as usual, normal anode. It do not have any perforation and all. This is one thing. The second difference what he did, he took the cathode somewhere in the center, close to somewhere here, which is having holes. But in this diagram, it is shown at one of the terminals, so it doesn't make any difference. Perforated cathode is important. The condition remains same, okay? The condition, Goldstein has also kept it same, that air at low pressure will conduct electricity. So the pressure what he achieved was 10 to the power minus 4 mm of mercury, and the current how much he applied was 10,000 volt. So at this condition, he also noticed cathode ray. Okay, so he also noticed cathode ray, and cathode ray was moving from cathode to anode. So this was cathode ray. After some time, he saw another type of ray, that is anode ray. Okay, I'll come to that. Let me just go to the theoretical content first. So Edwin Goldstein used modified cathode ray tube experiment or modified discharge ray tube experiment. Atoms are electrically neutral. It was told by Mr. Dalton. So hence, after the discovery of negatively charged electron, attempts were made to discover positively charged counterpart of electron. by using a discharge tube containing perforated cathode. This is example of perforated cathode, the holes. Goldstein found that some rays pass through these holes in the direction opposite to that of the cathode ray. Very good. These are also known as anode rays, okay? Because it was assumed that it is produced through anode, just like cathode rays were produced from cathode. At the same time, it is also known as canal ray. Canal ray, you know, heard about the English canal and all. Canal means where ships and all passes. So since this is a perforated cathode, something is passing through this. That's why the term canal was used, because it passes through these holes. So anode rays, because they seems to be coming from perforated anode used in the discharge tube experiment. I have highlight seams. I'll tell you why later. So this is the normal setup that Goldstein sir has used, the same concept of Thomson, and glass tube he took, vacuum pump to reduce pressure, a DC source, that is current source, a perforated cathode, and a normal anode. So initially, when everything was fine, when he applied pressure, when he applied the condition, cathode rays were seen to move from cathode to anode. Cathode rays were also there. But after some time, anode rays were seen. And when you see anode rays, suppose this is anode, and since it is a perforated cathode here, the glows were only in that area where holes were visible, not everywhere. Okay. Wherever holes is there, just opposite to it, the brightness was there, not on every counterpart. It is not completely full like this, the glow. It is only opposite of that holes what was there. Okay. So cathode ray concept, you know. Now anode ray concept, I have to explain you. Now it is known as anode ray, positive ray, and canal ray. Anode ray because it is coming from anode, positive ray because it is coming from anode which is positive, and canal ray because it is passing through the whole of the perforated tube. Okay, this is the concept, but this is not the thing which I am going to explain you now. Till now, whatever I have explained, you would have related that something is coming out of anode, but that is not the exact scene. Let me remove this first. Yes. Yes. So let me explain you now what exactly took place inside. Don't relate stuffs with cathode ray exactly. Cathode ray was coming from cathode, but anode ray is not coming 100% from anode, okay, as per the experiment. Now cathode rays are coming. Cathode rays, I told you that it is nothing. Now inside this, he used many type of gases, hydrogen, helium, argon, etc. Suppose the best result what he got was using hydrogen. So cathode rays, you know, it is negatively charged and it has mass. So when this cathode ray is moving at a high speed, it will come and hit this bond between H2 molecule. When it hit the bond breaks and you get 2H plus and you get 2 electron. These 2 electron added inside the cathode ray. Cathode rays were produced from cathode. Suppose 10. These 2 electron add there and make it 12. So this become part of cathode ray. Now this H plus what is produced? You know hydrogen atomic number is 1 like this. So it has 1 electron, it has 1 proton. Neutron part is not there because 1 minus 1 is 0. So since this is not having any electron, so this H plus entity itself is known as proton. Sorry, excuse me, sorry. So this H plus entity itself is known as proton. So Goldstein has not discovered anything which is coming from anode, but the gas what is there, it got ionized due to cathode ray. Got it? Again, understand. So what he did, he used cathode ray tube, cathode ray was there. So that cathode ray is having mass and charge. It is moving at a high speed in a straight line. When it come in contact with the gas which is filled inside, so hydrogen gas is there at a low pressure. So when it hit the bond break, electron is knocked out, comes out. This electron become the part of cathode ray because cathode ray itself is electron. And this H plus what is produced, this is known as proton. I have told you in acid base also that H plus is proton. So this he has discovered. And unfortunately or luckily, this is only proton because hydrogen, when it loses electron, it is left with only one proton. And this is the real proton which is inside the nucleus. So we know how to eat through spoon directly, but here the spoon is coming and going like this. So this is the discovery. Now, one thing you can ask, sir, hydrogen he has used and you tells that proton is discovered and electron is the part of cathode ray. I agree. If suppose oxygen is there, suppose I use cathode ray and cathode ray come and hit oxygen. So you get oxygen atom, okay? And electrons are out. I'm not writing how many electrons are not. I'm just writing electrons are out. So this become part of cathode ray. And suppose this is cation. It is having a positive charge. Now this and this is not same. So that's important. Your anode rays are dependent on the gas used inside. Whereas cathode ray was not dependent. Cathode ray is electron, and electron from whatever source it come, it is electron. But anode ray depend on the nature of the gas. If you change gases, the anode ray nature will also change. This is in the property next. Okay? I will give you a brief now. Edwin Goldstein, he know that atom is neutral according to Dalton's atomic theory. He also know that Sir J.J. Thomson has discovered electron. So to answer the neutrality of atom, there must be a positive counterpart to balance negative. So he used the same setup and at the same condition, the two changes what he made, he used perforated cathode somewhere in the center. What he sees that at 10 to the power minus 4 and 10,000 volt condition or 10,000 volt current and 10 to the power minus 4 mm of mercury pressure, cathode rays were also seen moving from cathode to anode and producing a glow on zinc sulfide screen. So a glow was seen here, okay? At the same time, one more type of ray was seen moving from anode to cathode side. Anode to cathode side, not from anode to cathode, and produce glow in patches behind the perforated cathode. Now, justification of cathode ray, how it is produced. Cathode ray is coming from cathode. Anode ray, from where it is coming, it is not coming from anode. The cathode ray is high energy, negatively charged particle. When it go and hit the gas present inside the cathode ray tube at low pressure, it ionize it by knocking out electron. So the electron knocked out become part of cathode ray, and this positive entity or the cation, if in the case of hydrogen, is known as proton. So this proton was discovered. Got it? Good. Now come back to electron. Electron discovery was done by Thomson. The name was given by J.J. Stoney. Proton discovery was done by Goldstein. Name was given by Rutherford. Discovery Thomson, name J.J. Stoney. Discovery Goldstein, name given by Ernest Rutherford. Remember that, okay? Now let's come to the properties of your anode ray, canal ray, or the positive ray. They travel in a straight line in the direction of opposite of cathode ray, obviously, because it has to move towards, this is positive entity, so it has to move towards the negative plate, and negative plate is cathode. That's why it is moving that side in a straight line. They are particle in nature. Particle means it has mass. Obviously, it has mass 1.673 into 10 to the power minus 27 kg. Okay, I'll tell you that later. It has mass. They are positively charged. They are positively charged particle. Charge is positive. Since they are positive, if suppose this is your cathode ray, anode ray, and this there is a electrical pole, positive and negative. And if this is your anode ray will deflect towards the negative side. Same thing with magnetic also. So they get deflected by external electric and magnetic field. They also affect the photographic plate. Reason, they are also charged and they also have mass. They are particle. They causes fluorescence on zinc sulfide screen. Reason? They have charge and they have mass. It depends on the nature of the gas used in CRT, the most important point, and the difference from, if someone asks you difference between cathode rays and anode ray, you tell that the major difference is charge and all, that is we know. Another major difference is cathode ray is independent on the nature of the gas used, cathode ray. Anode ray is dependent on the nature of the gas used in cathode ray tube. Cathode ray independent, anode ray dependent on the gas. So these are the 7 fundamental important properties of anode ray. Most of them matches with cathode. So this is easy, I believe. Okay, good. Now, after electron was discovered, after proton was discovered, Dalton tells that atom is neutral, proved. Now came the concept to measure mass, atomic mass. When atomic mass and atomic number was compared, there was a difference. So still we were not getting, there was now idea of electron discovery I have given to find out whether atom is divisible or not. An idea of proton discovery I have given because atom is neutral. That's why proton was discovered after electron. Now, after discovery of electron and proton, atom is neutral, we got to know. Neutrality concept is there. But the atomic number and the mass number values difference were there. Okay. Atomic number and mass number value difference were there. How to counter that? How to explain that? To explain the difference in atomic number and mass number concept, James Chadwick, a British scientist in the year 1932, he tried experiment to discover something neutral inside atom. Why neutral? Because atom, electron, proton already there. If you discover something negative, atom become negative. If you discover something positive, atom become positive. So there must be something neutral and it must have mass close to proton. That's why the justification will be given. Okay. Now, so he did an experiment. So after the discovery of electron and proton, Rutherford had predicted existence of neutral fundamental particle. Rutherford has predicted, but Chadwick has discovered. James Chadwick bombarded alpha radiation. Alpha radiation is represented like this. Alpha radiation basically means it has 2 proton and 2 neutrons inside it. Basically, it represents helium ion. It represents basically helium in the ionic form, and it do not have any electron. So bombarded alpha radiation at the beryllium foil. Why beryllium foil? He tried with various metal like potassium and all. Beryllium has given a better result. Rubidium and all also he has used. So beryllium foil. Polonium was the radioactive metal which gives alpha radiation. So James Chadwick bombarded alpha radiation at beryllium foil from polonium. This leads to the production of a neutral penetrating radiation. I will show you that in the diagram. This radiation was bombarded on a paraffin wax. Paraffin wax was used because it is very much rich in protons. Wax is a proton-rich surface. A hydrocarbon having relatively high hydrogen content. Hydrogen content means, you know, when it is ionized, this is proton. So the proton ejected from paraffin wax were observed with the help of ionization chamber and detected by the detector. So he concluded that usually penetrating radiation consists of neutral particle having nearly the same mass like proton, but difference is there. Proton is 1.673 and neutron is 1.675, 10 to the power minus 27 kg and minus 27 kg. This we will do later. So there is a slight mass difference. Neutron is slight heavier than proton, and electron is the lightest in mass. It is negligible mass. These particles were later known as neutron. So the concept or the idea, because any invention or discovery need idea. So the idea of neutron discovery was the difference in atomic and number and atomic masses. To explain that, this was done. So this is diagrammatic representation. So this is the alpha particle source, polonium. Alpha particle is positively charged. Now, when it hit beryllium surface, it removed neutron. Okay. So the experiment was set up such that neutrons are knocked out. Now neutrons, if you keep an electrical plate here, positive and negative, there was no deflection. So that is the meaning of this. That is the meaning of neutral fundamental particle and neutral penetrating radiation. It is neutral and penetrating means it is going inside the paraffin and hitting. Now suppose if I use a person of 40 kg, he is standing on a door and he is not moving. How to move him? If I ask a rat of 50 gram to go and move him, he will not move. So I will be using a person of similar mass. Suppose I use a different boy of 42 kg mass. So he will go and push him so that he move out of he will unblock the door, right? So to remove this person of this much mass, I need either similar mass or slight more. The same concept is used here. So the neutron which is coming out is having similar type of mass like that of proton. Then only proton is knocked out. Otherwise, proton will never knocked out if the mass of neutron is less. So paraffin wax is rich in proton. That's why it is coming out. And this is the detector. So if I put a electric plate, you see that most of the protons will move this side. So here no deflection, it means that it is neutral, and here deflection, it means that it is positive, because here it was negative and here it was positive plate. So it is moving towards the negative side. So when I put an electric plate on neutron side, no deflection, telling it is neutral. And when I put an electric plate on the proton side, it deflects towards the negative side. This tells that it is what? Positive. That's right. Any doubt in this? No. Again, to some brief extent. Polonium, it is a radioactive metal. It produces alpha rays. Alpha rays is just like helium ion. It is positive charge rays, or you can tell that it is positively charged, highly ionizing. It produces ions. So when it hit beryllium foil, it remove neutron. So when electric plates are there, no deflection. When it go and hit the paraffin wax, since the mass of neutron and proton are comparable, neutron is slight more, the protons are deflected out, removed out. Now when I put a electric plate with negative and positive terminal, the proton move towards negative, that is detected. So it tells that proton is positively charged and neutron is negatively charged. Therefore, neutron was discovered by James Chadwick. Name was also given by him. So that's all the discovery of electron, proton, neutron. So in today's session, we have discussed about atom, the timeline of atom, that from 13.7 billion years ago after Big Bang theory, and Aristotle, Democritus, Dalton, Robert. There are many more. I am not going there. Then atom is made up of three fundamental particles, that is electron, proton, neutron. How electron was discovered, how proton was discovered, how neutron was discovered. Now neutron, few properties I am telling you. Basically properties of neutrons, they are neutral. Okay, so that you keep in mind. And straight and all, it's not required because it is neutral, and neutral thing cannot involve in many reactions and all, so we don't talk on that. Now the discovery, the comparison between electron, proton and neutron we are doing here, a comparative study, whatever we have done. In when you come to classroom, we will tell you even more than this. So proton are positively charged, which is represented as P plus. One more thing, I will go back and tell you that proton discovery, so that it will not, I don't want to go much in depth. So beryllium foil was used. So beryllium was used, and alpha particle, you know, I said that it is like helium. So beryllium is 9 and 4. That is the difference, okay? If it is 4, then why it is 9? It must be 4 also, no? 4 and 4, because neutron is involved, and this is 4 and 2. So when it goes and bombard on this, what you get? You get carbon 12 and 6, and you get neutron 1 and 0. So this is the reaction which was seen here. So I thought to avoid, but I feel you will digest it. That's why I'm giving it. So beryllium, when it bombarded with helium or alpha particle, basically the reaction look like this. You will get carbon 12 isotope and 1 neutron. So 9 plus 4 is 13. So 12 plus 1 is 13. And this is 4 plus 2, 6. It is 6 plus 0 is 6. That's it. Coming to difference, so this is proton and neutron is represented as n naught, and electron is represented as like this. So they are neutral particle and they are negatively charged particle. Particle means mass. They are present now. If suppose this is an atom, your protons and neutrons are present in the center of the atom, and this is known as nucleus. Whereas electron keep on revolving here in its particular orbit, in its particular shell. So they are present in the nucleus of all atom, and neutron, they are present in the nucleus of all atom except hydrogen. So hydrogen, it is 1 and 1. So it has 1 electron and it has 1 proton. So 1 minus 1, it has 0 neutron. Neutron is not there. So we are not talking about that. How to find out neutron? Suppose this is carbon 12 and 6. So it has 6 electron, it has 6 proton, and 12 minus 6 is 6 neutron. Same thing you can do here. 1 minus 1 is 0 neutron. So except hydrogen, neutrons are present in every atom in their nucleus. So they are present in the outer shell within an atom, an orbit. Basically, they keep on revolving around the nucleus in its particular orbit. Orbit means a specified path. So the mass of the proton is taken as 1 unit positive and equal to the mass of neutron, but it is slight more. So the mass of neutron is considered as 1 per unit, and it is equal to the mass of proton, and the mass of electron is negligible, high, it is 2 less. So it is 1 by 2000 times less than the mass of the hydrogen atom. Proton is represented as P, N, and E. I have given you a better way to represent. Remember this. So this is a comparison between them. When you come to classroom, we will tell its charge, we will tell its mass, we will tell various other things in Coulomb and all, the charges and all. So that's all from this session today. 5 questions, homework for you, assignment. So which of the 3 subatomic particle, which of the 3 subatomic particle is the lightest? So out of the 3, which is the lightest, meaning is that which 2 subatomic particles are found in nucleus? You need to now, you must be knowing the answer. So name an atom in which nucleus of an atom does not contain any neutron. अभी किया है, according to Goldstein नहीं बताऊंगा. So these are the 5 things which you need to do it. So come prepared and solve next class. So I hope this is clear. What is atom, electron, proton, neutron, discovery, and its comparative study. So that's all from my side today. So take care of yourself. बच के रहो कोरोना से. Respect your parents. Respect your teachers. God bless you. Bye bye. Take care.